Good afternoon, GeeCON. It's exciting to be here back after a small pause. Yesterday, Chris Tallinger at the party told me that to have a successful presentation, you have to do something in the beginning that just shows that you are just everyday normal guy, that you still make mistakes. So I'll try this warm welcome. Dzień dobry, Kraków. I don't know if Sebastian is here, but he challenged me yesterday that I won't do it. So I did it. As at every presentation, there is a slide. This is room 1. So you can ask the questions, a continuous questions delivery. If you shout out loud, I'll probably answer it anyway. But we can do Slido. And we'll be talking today about testing and testing triangle and how we can do the test right when our architecture evolves. Because the test triangle is something that is ages old. It's like decades, probably. And this has this concept of, integrating everything all together and doing the test. And this totally doesn't work when it comes to more modern architectures. When we start doing microservices, when things become independent, it's harder and harder. And even if we try to have this monolithic test combining everything all together, hard to maintain, hard to assemble, takes hours, ages. When I did this presentation 2 weeks ago on a different conference, I asked people like, how long does it take for your complete test suite to run? Is it like 10 minutes? For whom is 10 minutes to have everything working? Okay, for whom is half an hour? Yeah, an hour? Half a day? 2 days? That's exactly. So we have this struggle of tests running just too long, and we'll try to challenge it somehow. So my name is Jakub Marchwicki. I came from Poland. There was a joke about Dzień dobry, Kraków. I like it. So I work in Hazelcast, but I will not talk about the product itself. I work for the Hazelcast Cloud, and we try to build Hazelcast in the cloud as a managed service. And when you build stuff in the cloud, it just gets more complicated and harder to test and harder to deploy, and things are moving not always in a way that you're in control. So to manage that, you have to rethink how you're testing things, and this is what this presentation will be about. So let's start. We have our triangle, we have unit test, integration test, and some UI end-to-end, however you call it. So in integration test, we just put everything. It's like API test, database test, some caching, third-party systems we integrate with, tests, whatever. And we probably can attach a funny picture to each of those. Like we have integration tests that don't really test the exact flow. We have the UI tests, which are totally frustrating and never works, and it's just pain in the back. And we have unit tests that don't really test anything, because we've mocked out everything, including database, and we prepared it's all fine. But it isn't. So on the top of that, when you deploy your stuff to the cloud, you have this another abstraction layer that you don't really know how to test. And think about testing integration with the database on your application, where your database layer is through Hibernate, which you feel is a good abstraction, and then you run your test with some embedded database because it's faster. But on production, you're using Oracle, which is just different. And the test pass, but the deployment fails. Application doesn't work. So yes, that's our daily life. And now we'll have to think how we can do it better. And despite all these problems with the test itself, we have the concept of microservices, where we have independent deployable units, which we don't really know how to assemble all together and do these real end-to-end tests. And whether end-to-end test is still a thing, whether we just stop caring about this end-to-end flow and do it differently. We just cannot deploy the whole platform on my laptop. Like, my laptop is 64 gigabytes. And when I try to deploy everything, it turns into a useless drone trying to fly with all the ventilators running. So it just doesn't make sense. On the other hand, we want our tests to be fast and efficient and run quickly, like in 10 minutes, some of them said, at most half an hour. And then we can't just deploy everything. If our application is using 2 Kubernetes clusters, so am I supposed to deploy 2 Kubernetes clusters in my integration test? Doesn't really make sense. So to think about the testability in the context of individual services, let's start with a classic archetype of a microservice. If we look from a pretty good distance, we can say that our microservices is our code, the business logic we've implemented, a bit of framework. In this presentation, I will use Spring Framework examples, but any framework will do. And then we have some external services, some databases, and we expose some endpoints, whether it can be HTTP or any other communication, and some logs and some monitoring. And as we step up through the testing triangle, we should have different approaches for testing different parts of this code. And then you have this plethora of test toolings, and people just say, test containers are good, use it for everything. And other people say, integration tests in your framework are good, use it for everything. And the third bunch of people say, well, integration test is bad, just smoke out everything. And it's harder and harder to sense what's the good approach, where the good tools, where the tools should be used, and not the tool themselves. So this presentation will focus on how to apply the tools rather than, or where to apply the tools rather how to exactly use them. So when it comes to unit testing, there's nothing to say. We just unit test. And we have to do it, and it must be fast. Like, unit tests, it should be milliseconds, no I/O, no wire mocks, no database, containers, web servers, just plain units. And that's usually good enough. But it's not good enough for us to get an assurance that what we've built or what we've coded and what we've tested will really work. We've checked some minor bits and pieces, but we would like to get answer for different questions. And in the context of microservices, there's a number of these questions, like, will it start? If I assemble my deployable unit, will it even start? Because in real life, on production, it runs in Docker container. It runs on Kubernetes. It has some sidecar attached to that. And my unit test will not tell me whether this will still work. And I could have broken it. And then, if it starts, there's a question, can I deploy it? Is it safe for me to deploy the service? Does it still meet the expectations others have for this particular service? I've been providing some data. I've been exposing API. Does it still work? Is it still backwards compatible? My unit test won't tell me that. And then, will it deploy? So, even if it starts and it's safe for me to deploy, will my deployment pipeline pass through? Will I have problems with deployments? It can be different set of environment variables on production environment that I have to set up somewhere or I have to define somewhere. And I don't know if it works. I don't know if my service accepts these environment variables at all. Then will it run on production? will it successfully connect to the backing resources it should connect? Like, will it read from the database? Is the schema on the database correct? Or have I done any tests to make any validation if that's still working? And then finally, the API changes, the providing data, consuming data, all those things that goes beyond the unit testing, and this is something we'll need to test as well. So let's tap one level higher. We would like to test not only our code, but our code in context of the framework we are running it with. So imagine Spring Framework, but also any other. It provides you a lot of stuff like JSON mapping. If you use Spring Framework, out of the box you have some configuration of the object mapper from JeeCON, and it just works. Or for example, together with starting the application, we initialize some caches, and we would like to be sure that they are still working and they are populated correctly or they are evicted correctly. That's between our code and the framework, and this is also something that needs to be tested. So what's the struggle? Imagine this very simple or simplistic JSON, which we are sending over the wire. So as we are sending it back and forth, in our test suite, I would like to be sure that once I receive it, I know how to unmarshal it. How to create a bean out of it, how to create an object in my Java world, and then how to serialize my object to this particular string representation. I would like to make sure that it's still working. So yeah, I'll do an integration test. I'll do a test with Spring Framework. You see JSON test annotation, which is a specialized annotation from Spring, and then I inject my object mapper, and then I do my test. I have a string representation and try to get an object out of it, and the other way around. And some people might say, hey, you're just using the framework and it takes some time to start, whereas you could have done just this. And you could have just created a new object mapper. Well, yes, but then I'm not exactly testing my code in a context of its production runtime, because on production my object mapper will be injected, because the default object mapper configuration coming from JeeCON is a different one than we have in a Spring Framework. And even though this test potentially will pass, if I do a subtle change and go from camel case to snake case, this test will fail. So that's why I try, when I step out of my unit test and go to the integration testing, I try to get or mimic or use the production configuration that's coming with my application. I fight furiously all different flavors of configurations of all different profiles in my application. I like my app to have a single configuration, and this configuration can be only driven through environmental variables. So not 5 different configs for different environments, a single config and just tiny changes. And that way, when I inject my, for example, object mapper, I know that in my test it's configured in exactly the same way that's on production. That gives me a step further in my assurance, in my security zone, because I don't trust myself when I code. I call it basic integration test. So I try to check if I've applied my framework correctly, if the configuration files are read correctly, are objects serialized and deserialized, and does the app work with all the external dependencies being abstracted or just removed? Just with the framework. And that takes me from approximately less than 100 milliseconds to run my unit test to about a second to run my single test with Spring Framework integration testing. You can argue whether it's good or bad. I'll say it's not that bad. Why? Because I'll ask you a question. How many of you are using Mockito? Most of you. And are you using Mockito extension to use annotation to mock your classes, or you mock them individually? And do you use inject mocks from Mockito to resolve all the dependencies, or you do it on your own? Who is using Mockito extension? You do it because you're lazy, aren't you? And the performance kick you get from Mockito extension is maybe not as significant as the basic Spring framework, but it's comparable. And in most of the cases, people don't even think about it, but start to challenge. Spring framework is heavy, it takes a lot of time. And as we talk about time, why it's important, a friend of mine, Jakub Marchwicki, who will be doing closing keynote tonight, coined this term of testing budget. That when you do testing, you have a budget, but the budget is not derived in money. It's just about time. And you want your tests to run quickly within 10, 20, 30 seconds, depending on the scope of testing. You want them to be fast. And that's your budget. And you have to do everything that's possible to stick within this budget. So why it's important? Well, you can say, well, that saves time. Yes, it does, but saving time has another effect on us as a human being. Because we talk about time for a very particular reason. When we wait for the test to finish, and the test finish in less than a second, like 100 milliseconds, we have the feeling that the system reacts instantaneously. There is no delay, there is no extra feedback. We just run the tests and boom, result. Run the test and results. But then as test gets longer and it takes about a second, we get into a kind of a limit of our uninterrupted zone. We see that, okay, it's working fast. We noticed some delay, but we are still in the same context. We are not bored. We don't start to look around. We don't start to think about something else. But then when the threshold goes up and it's more than 10 seconds, we go beyond the limit of users' attention, of people's attention. And if your test starts to run like 20 seconds or 30 seconds, what you start doing? I open my browser because I get bored and I'm not fan of log scrolling through my terminal, so I'd start doing something else. It goes beyond my uninterrupted attention. And this is not something I just invented. This is coming from late 60s, from the user experience researchers and how we get bored pretty quickly. So this is one of the reasons why we need our tests to be fast. And to get our test fast, we either have to, well, if our tests are not fast, we either have to build up something that will tell us that the tests are done and we can get back where we were at that point in time, or we have to invent some other tools, and those tools is about applying the right test in the right places. Yeah, so let's get to our code. So we have the unit tests, tested, whatever, done. We have our very basic integration test where we tried our code together with the framework, and it was fine. It started. We knew that the configuration is correct. And then as we go further, our service exposes some data. Our service consumes some other services. And we would like to verify that. We would like to know that our internal HTTP clients are working correctly. Not that code that encapsulates HTTP client is working correctly, but that there is an actual HTTP call somewhere and it goes over the wire and connects. I would like to have at least a few tests doing that. And then these other services expose some data, and I'm consuming that. So I would like to make sure that what I'm consuming at the moment is what they will be providing in runtime on production environment. And then the same applies to me. I expose some data. I have some data structures that I will be providing to others. I would like to make sure that my data structures are still backwards compatible. I would like to make sure that what I've coded is not breaking somebody else. And then the actual data that they're consuming, the over-the-wire call, the HTTP call that they're doing, I still would like to be sure that the interface that they have been calling hasn't accidentally changed. So now we can deploy another set of unit tests, or another set of integration tests where we try to verify it. The basics. The wire mock. We'll use wire mock to set up an application server, we'll also stub an application server, and try out our HTTP calls. That's fine. We know that the actual internal client that we are using, this code, will do over-the-wire call to some artificial HTTP server and download the data. Great. But we aren't even sure that what we are testing against is the real service. Well, it's kind of our imaginary view of how that service will behave or what data it will expose, not the actual data. So we have to go further. We can roll out contract testing. So we can set up our task. This is a packed contract testing example, where we as a service build some expectations, build some schema or some examples, how we will be using the other service. So we as a consumer try to be very explicit what we are looking after, what we would like, what are our expectations. And then on the other side, on the provider side, if we have an infrastructure correctly set up, they can take those expectations and check if what they're exposing, if what they're doing still makes sense. That's the PACT's idea of the contract testing. When you go to Spring Cloud contracts, so the Spring framework for the contract testing, they have slightly different notion. They go for the contract first. So parties agree what will be the payload, what will be the actual HTTP call, and then collaborate on that. But essentially, they are looking for exactly the same way, for exactly the same thing. They are looking for a way to make sure that the consumer is the one side, the consumer part, is utilizing the actual workloads that the provider is responsible for. So not just calling an imaginary friend over the wire mock, but more of a real service. And then the third part, because we have this contract-based collaboration, but sometimes it's really hard to set it up. Sometimes I don't have a peer. I don't know my consumers because I'm just publishing a public API. Or it's really hard for me to do this contract collaboration. So there is a middle ground. I can do something in the middle. I can, for example, based on my Swagger documentation, set up a comparison where I take a reference pack, so reference Swagger of my service, and the Swagger that I've just generated in runtime with my changes, and then validate whether these things are compatible. If you're using gRPC, there is a buff project around gRPC that's doing exactly the same. That checks whether your gRPC protos are still backwards compatible. Obviously, you can say it has ups and downs. It's good to stay backwards compatible, but then you have to rethink how you stop being backwards compatible at some point because you don't want to. You want to evolve your service. So there's no free lunch, but there are a lot of stuff that we can do to make sure that we are not accidentally breaking stuff. And this is what we're doing when we have our code, our framework, and the surroundings. And then there are some additional things that, for example, we can not only use HTTP back and forth. We usually do, but sometimes it's not enough. We can have a database, or we can have a caching, like the Hazelcast for the cache, or Redis for cache, or we can have some Kafka or whatever. We can have some other infrastructure parts that we'll be consuming or will be dependent upon, and would like to check whether the expectation about the behavior we've baked into our code still holds when we go to a real world. So we can try using like embedded Redis or Kafka rules or embedded Hazelcast to get these basics correctly. And that gets us to the advanced integration testing. That's how I refer to it. So we are trying to write to the database. We try to get the I/O integration correct, whether it's sent over the wire, exposed to HTTP, whatever. We try to validate the APIs we provide and we consume. When we do messaging, then I try to get the real data through the messaging system, just to know that my serialization is correct. For example, some message brokers are using binary data, some other are using by default textual data. And if I get my serialization off at some point in the middle, all of a sudden my message is corrupted. And I would like to double check it within my integration test. I would like to send something over to my message broker and consume it and see whether I can do it. So whether stuff I've configured is still configured correctly. But then people say it takes ages to run those integration tests. And this ages very often comes from us developers not understanding what we are doing. A short quiz. Imagine this small code snippet, a very basic Spring Boot application test which triggers the application context and just let it load and nothing else. And we have 20 tests like this in our module. So how many times will the Spring context be initialized when we do our test? Who is for just once? Who is for 20 times? Yes, you just proved me. It's just one time. Because Spring context is quite smart in how it runs its integration test. I'll get to this later, but there's another quiz time. Similar stuff. We get test containers. Who's using test containers? Quite a few people. Who knows what's test container? Much more. Okay, so we have this test containers. So we are trying to run a Docker container within the scope of our testing. This is MySQL, and we'll just initialize the MySQL container and run a test. If we have 20 tests like this in my module, how many times will the MySQL will MySQL be started? Who is for once? Who is for 20 times? Who is not answering stupid questions? That's what I thought. 20 times, because test containers don't do any caching by default, and you have to do something about it to not constantly initialize the same container. So for Spring context, if you get deep into test context of Spring Framework, you get this text context holder, and Spring deploys a lot of sophisticated logic to figure out whether your test context is still the same as it was in the previous test. And if it's the same as in your previous test, it'll just reuse it. So if you do your test correctly, if you do your tests right, it will just run once or a couple of times in your whole module, just reusing the same test context. So your test will be pretty fast, or can be pretty fast. But with the test containers, it will just start the container over and over again. So you can get to a situation that in your test suite you will get your MySQL started 20 times. 20 times about 15 seconds, depending on how fast is your machine. That's a lot of time. You can do it only once. And many people just do some persistence extension if they want to be really sure that it's only once. So they artificially start up the MySQL container and keep it running, and therefore change their testing architecture or the testing assumptions a little bit, just to randomize stuff. On the other hand, you can go to test containers and force it to reuse containers, but it's very local. You can do it on your local environment, and then you'll have to do it again on your CI/CD pipeline. It's totally up to you, but there are ways to do it, and you have to think about it, because nothing comes from free. Back to tests. We got the units, we got the framework, we got the basics around like the HTTP. And we would like to test kind of our whole service as a unit. We verified business logic. We know that the bloody thing is starting. But we haven't really tested how it behaves with all these backing resources that we have in our production infrastructure. Like think about 12-factor application. We have this backend services, we have the databases defined through environment variables, and we would like to make sure that we haven't broken something, that it's still working, that we write something to the database, we consume something from the queue. If our application is supposed to run in a high availability mode, it really runs. If it reads data from the queues, it's like passive active, if that's our choice, or it's active active, and two consumers are consuming data. And if we have some distributed logs for whatever reason, it's still working. That's what I would like to verify as well. So at some point, I would like to get some happy path scenario passing through my application, which is set up nearly as if it was set up in production. So that whenever I deploy, I have a fair confidence that it's still working. So this is an example of a setup of plumbing, of this kind of a nearly black box example. A lot of code where essentially we just test if we do ping to our application, it responds with pong. A lot of plumbing for a very simple use case. The thing is, I would like to test with a real database, with a real queue, with the same queue version that is on our production, with the same MySQL version that is on our production, just to make sure that there is no space that there might be something a little bit off that will just make my application crash. And the good thing about this is that I can still fine-tune the configuration of my application. And the bad thing about this test is that I can still fine-tune my configuration. Because sometimes it's very helpful to be able to set up everything and then just inject a slightly different configs. Like, well, yeah, on production we're using HTTPS, but I don't really want to fiddle with all the keys and the key stores, so just use plain text here. That's very helpful. You still kind of verify quite a lot, but you just make it a little bit simpler. But on the other hand, there might be things that you've overlooked, or that might be things that you haven't really checked, which comes from framework or from external configuration. There was, with Spring, for example, quite recently, there was a change. It wasn't backward. It wasn't a bug. It was a change that some parts of the actuator services start requiring implicit authorization. So out of the box, it was secured. So the same configurations, everything was the same, but all of a sudden, application stopped working. Because my health endpoint that was used by Kubernetes to check whether the application is ready was secured and it was answering not authorized. I haven't changed anything. I just raised the version of the Spring framework. So this is exactly what I would like to check. No changes in configs, just run as if it was on production, and see what happens. We can go further. We don't need to care about this configuration. We can just deploy everything. Set up like Docker Compose, define all services in the Docker Compose, then set up environment, say just, you have this Docker Compose file and just run it. And there's like the RabbitMQ and database, just expose it, and my service, make the highly available, at least 2 instances, and then run. And the only way for me to fine-tune this configuration, to look inside my app and change it, will be exactly in the same way I'll be doing it on production, through values on my through values in my Helm charts, or through environment variables. That's how I'll do it on production. That's how I'm going to do it in my tests. The downside, this can take like 5 minutes to run. That's a lot. So if I do all my testing like this, I'll be screwed. It'll take hours. If I don't any test like this, I'll be screwed. I won't even know if my single service starts and behaves correctly on the prod. So we are here very close to checking, how the code will behave when it leaves on my local machine and goes somewhere to production. And we try to mimic as much as possible. We probably can't do everything, but it gives us some assurance. I call it black box test, and that's how many people call it. So we integrate all the layers, including databases, including external calls, production configurations, whatever. If our app have some readiness checks, liveness probe, we can check it. If our application exposes some Prometheus metrics to scrap, we can check it. We can check it as close to production environment as quite possible. That's things that we cannot check. Like, if you deploy your application in like the service mesh architecture, while you, at least I don't know how to, can't really simulate service mesh on your local PC. That's hard. If you're running in Kubernetes, there might be some networking issue which you really don't simulate through Docker Compose or Docker containers. You can do a bit, but not everything. Now the thing is, as you go forward with that, it gives you a lot of space to fiddle with those real problems on production with networking, rather than correcting stupid mistakes that you overlooked in your standard testing pipeline. Can we do more? There are some organizations that are very spec-driven, that are very that have some compliance things to comply with whatever. I never really understood it, but I've come across situations where they say, well, we can't really start developing unless we define some user scenarios, how that's going to work and how it's going to be tested on the higher level. That's fine. If you know Cucumber and BDD, you can define your scenarios, and going from here to a black box test, it's fairly simple, because that's your scenario and that will work with your black box test, because your black box test pretty much contains everything. And that might also help you define how many of those black box tests that you will really need, how many of those scenarios are needed for the compliance or for whatever other people will require that. And that's how you can drive it. Yeah. We've walked through a couple of scenarios of testing. And how I approach it is, we try to answer ourselves a few questions. Will my application start? Will it deploy? Can I deploy it? And will it run? And we can look at answering those questions through different angles. Through the angle of speed, how this test will run, how fast they will run. How much can I change about the configuration? how elastic it is, how much stuff I can put it in and change, and then how reliable do I feel those tests are. And then we have unit tests, blazing fast. I can do everything, but they give me little to no reliability that what I've implemented really works. This is like the basics. But then if I go up and up, so I have this integration test with mocks or with like the basic framework. It's slightly slower. It still gives me a lot of abilities to change the configuration, to manipulate my context. But still, I don't feel they are really reliable. I've seen a lot of cases that a lot of tests were deployed, but they weren't really testing anything. They were just testing a very small vertical slice of my application, giving me no context whatsoever. And then I go to the integration test with containers, with real system, with real HTTP calls, whatever. That gets slower. Still, I can change a lot, but on the other hand, I got a lot of reliability. I know that if I expose this HTTP endpoint, it really works. And I haven't accidentally changed post to put or get to patch or whatever. I still have a test that verifies it. And towards the end, I have the black box test. Slow. Little to no modification of the application context. If I haven't programmed it in a way that I can accept some external changes, I can do them. But once it runs, it gives me a lot of assurance that this will pretty much work the same way when I go for production. Or when it doesn't, I pretty much know where is the problem, because I've tested a hell of a lot of stuff around that. Is it all? Can we test on production? Well, people are not happy with testing on production, so I'd rather say, can we experiment on production? When we wrote this whole lot of tests internally in our project, then we are kind of flexible, or we're kind of easier to get out to production and start experimenting. Start to play with metrics, start to play with logs, so kind of see how the application behaves in runtime and what it tells us through metrics and logs. See application traces, do some chaos engineering, turn off a node, turn off a few nodes, kill a service, whatever. This is something that you can't really do in your local environment, on your laptop. And this is something you can't really do when you're chasing stupid bugs that you've overlooked in your development process. But when you covered your stuff correctly, and you know it's fast to build, and you know it's covered in a best possible way, and it takes a few minutes to build and deploy, you're far more flexible with getting out to production environment, experimenting. Because worst case scenario, I will redeploy, and after 5 minutes, it'll be good, all good again. Obviously, that depends where you are. I wouldn't do it with my payment service or some customer data. But logging in, logging out, well, small outrage never killed anybody. You can play with feature toggles, you can introduce features and you can hide them, and you can just experiment on production. You can start with canary releases, you can deploy things independently, and you can do all this stuff that you haven't really thought about it because you were chasing the stupid bugs which you haven't covered in your unit test because you couldn't. And that's for me. I'll take some questions in Slido if there are any. Thank you very much, and enjoy the final keynote after the break. That's hard. Yeah. So what's the reason for testing external dependencies? Slide with serialization. External dependencies should be tested before release. For others, so JSONs has been tested. What's the reason for testing external dependencies? So what do you mean by dependencies is external service? Is it correct? That's how I understood it. No?
For example, you had in a slide where it's testing JSON implementation for serialization and deserialization. So what's the reason for that?
Because for example, in the Spring Framework, the object mapper, so the actual serializer and deserializer, can be configured in the different ways. And this configuration is coming from my application configuration. Springs comes with opinionated configuration for the object mapper. And it's different than the default one, which comes from JSON. So in my test, I would like to make sure that some edge cases of the JSON serialization are covered, so I know something holds me from accidentally changing the JSON implementation, because that will just break on production if something changes. If, for example, instead of using a default object mapper coming from Spring Framework, somebody creates a bean and do new object mapper, the app will compile, the basic scenarios will work, but some edge cases about, for example, date serialization or camel cases versus snake cases, that will fail. But on the other hand, I would like to fail fast. I don't want to wait until the very, very end when I have everything deployed and then check whether the serialization works. This is a small slice I'm testing, and that gives me very early feedback. Do you really get feedback? I'll jump to the next question, Michal. Did you really get feedback in less than 1/10 of a second, 100 milliseconds? What about compilation time? So a basic unit test takes from 50 to 80, maybe less than 200 milliseconds to run, including compiling. It's in the IDE called starting. If you recompile everything in your Maven, that takes the Maven time, but then individual tests run pretty fast. That's kind of not scientifically measured on my laptop. Yes, less than 100 milliseconds is possible. Based on which research times of user patience base? I can, after the questions, I will get back to this slide. There is a research from, I think he's called George Miller. It's from the late 60s. There was research about user cognition. It's very widely used in the user experience design when you try to measure response times of your web app. But as it's based on human cognition, that's kind of universal. I will get to this exact research paper after the questions. Shouldn't we avoid mocks in favor of test environments of dependency? Things may behave differently in real database engines and services. Yes, that's totally true. Though, when your service has a number of dependencies, I try to avoid all the time testing everything together. I have tests that test everything together, that checks the configuration. Then I have tests that verifies that my entity configuration, for example, for Hibernate, is correct, that the mapping between the database and my code still holds. And that's where I use real database. But once that's done, I'm not intending to test Hibernate framework. There are other people who have done it, or any other persistence framework. So I want to do the test which I could have broken. So when it's Hibernate, it's the configuration. When it's like JDBO or some simpler database mappers, I want to try the individual queries in my repository. That's where I use the database. But once I'm done and my service not only uses database but uses some other services to perform, like validation or some additional checks or whatever, and it's not fully dependent on the database, I'd rather mock the database out, because I've checked the behavior, I've checked that layer, and I'm not interested in that anymore. I can do other stuff. So I try to slice it, usually to avoid spending and constantly running the database service again. Is it a comment from Michał Beck? Mapper may behave differently in different configs, so some breaking changes may also change it. So we should test it too. Yes, that's what I try to do. If there are no other questions, I will get to the slide on the... that's not the thing. How? The timing. And this is the research paper. 3 important limits. It's George Miller, 1968, and there was some additional research on that topic. If you Google 3 important limits, you would probably land in the Nielsen-Norman group, which is one of the biggest user experience research groups, and they are elaborating on that as well. That holds not only for user experience as if website, it holds for everything, including, I don't know, response times from your refrigerator, whatever. So thank you very much. Enjoy the break and enjoy the final keynote.